In the vast expanse of the cosmos, billions of stars twinkle like celestial fireflies. Orbiting these stars are planets, an eclectic mix of celestial bodies with their own unique stories to tell. For centuries, humanity has gazed upon the stars and pondered a profound question: are we alone? The discovery of exoplanets, planets beyond our solar system, has breathed new life into this age-old question. Among these distant worlds, Gliese 12b stands out as a particularly intriguing neighbor. Gliese 12b is an exoplanet located approximately 20 light-years away from Earth, a cosmic stone's throw in astronomical terms. Discovered in 2011, this planet has captivated the attention of astronomers and astrophysicists worldwide. Its allure lies in its remarkable similarities to our own planet Earth, hinting at the tantalizing possibility of another world that could support life as we know it. The discovery of Gliese 12b marked a pivotal moment in our understanding of the universe. What makes Gliese 12b so special? Its size and temperature are key factors that contribute to its intriguing nature. With a radius only slightly larger than Earth's, Gliese 12b falls into the category of super-Earths, planets that are larger than Earth but smaller than Neptune. This size range has proven to be particularly common among exoplanets, suggesting that planets like Gliese 12b may be abundant in the Milky Way galaxy. The temperature of Gliese 12b is another factor that has piqued the interest of scientists. While its exact temperature is still being debated, estimates suggest that it may be within the habitable zone of its star, the region where temperatures are just right for liquid water to exist on a planet's surface. Liquid water is considered an essential ingredient for life as we know it, making Gliese 12b a prime candidate in the search for extraterrestrial life. However, the habitability of Gliese 12b is not without its challenges. Its host star, Gliese 12, is a red dwarf star, much smaller and cooler than our Sun. While this means that Gliese 12b orbits its star much closer than Earth orbits the Sun, it also presents some potential obstacles to life. Red dwarf stars are known for their intense flares, sudden bursts of energy that could be detrimental to life on nearby planets. These flares could strip away a planet's atmosphere or bathe its surface in harmful radiation, making it difficult for life to gain a foothold. The habitability of planets orbiting red dwarf stars is an ongoing area of research, and the answers may hold clues to the prevalence of life in the universe. Red dwarf stars, despite their diminutive size, are the most common type of star in the Milky Way galaxy. They are much cooler and fainter than our Sun, emitting most of their light in the infrared part of the electromagnetic spectrum. This means that planets orbiting red dwarf stars would need to be much closer to their stars to receive the same amount of energy as Earth receives from the Sun. While the close proximity of planets to red dwarf stars might seem like a disadvantage, it also presents a unique opportunity for astronomers. Planets orbiting close to their stars are easier to detect using current astronomical techniques, making red dwarf stars prime targets in the search for exoplanets. The transit method, which looks for dips in a star's brightness as a planet passes in front of it, is particularly well suited for finding planets around red dwarf stars. However, the close proximity of planets to red dwarf stars also presents some challenges. As mentioned earlier, red dwarf stars are known for their intense flares, which could pose a threat to the habitability of nearby planets. Additionally, planets orbiting close to their stars are more likely to be tidally locked, with one side always facing the star and the other side always facing away. This tidal locking could lead to extreme temperature differences between the day and night sides of the planet, making it difficult for life to evolve. Despite these challenges, the abundance of red dwarf stars and the relative ease of detecting planets around them make them exciting targets in the search for life beyond Earth. The habitable zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. This zone is not a fixed distance from a star, but varies depending on the star's size, temperature, and age. Planets too close to their stars would be too hot, and any water would boil away, while planets too far from their stars would be too cold, and any water would freeze. The habitable zone is a crucial concept in the search for extraterrestrial life because liquid water is considered an essential ingredient for life as we know it. While life may exist outside this zone, it would likely be very different from life on Earth. The discovery of planets within the habitable zone of their stars is always an exciting event, as it raises the possibility that these planets could harbor life. However, it's important to note that being within the habitable zone is not a guarantee of habitability. Other factors, such as a planet's atmosphere, its magnetic field, and its geological activity, can also play a significant role in determining whether or not it can support life. The search for life beyond Earth requires a comprehensive understanding of all these factors, and the habitable zone is just one piece of the puzzle. At a distance of roughly 20 light-years, Gliese 12b is relatively close to Earth in astronomical terms. This proximity makes it an ideal target for study with current and future telescopes. Astronomers can use powerful instruments to analyze the light coming from Gliese 12b and its star, revealing clues about the planet's atmosphere, temperature, and composition. The proximity of Gliese 12b also makes it a prime candidate for future missions to search for signs of life. While sending a spacecraft to another star system is still a daunting technological challenge, the relatively short distance to Gliese 12b makes it a more attainable goal than other exoplanet systems. In the grand scheme of the universe, 20 light-years might as well be next door. This cosmic proximity provides us with a unique opportunity to study a potentially habitable world in unprecedented detail. Gliese 12b serves as a tantalizing reminder that the universe is full of surprises and that other Earths may be waiting to be discovered. The exploration of exoplanets like Gliese 12b is not just about finding another Earth, but also about expanding our understanding of planetary systems and the conditions that give rise to life. Each new discovery brings us one step closer to answering the fundamental question: are we alone in the universe? The James Webb Space Telescope, launched in December 2021, is the most powerful space telescope ever built. With its advanced instruments and large mirror, JWST is capable of observing the universe in unprecedented detail, peering back in time to the early universe and studying distant objects with remarkable clarity. One of JWST's primary science goals is to study exoplanets, including Gliese 12b. The telescope's sensitive instruments can analyze the light passing through the atmospheres of exoplanets, revealing information about their chemical composition, temperature, and even the presence of clouds. JWST's observations of Gliese 12b are expected to provide a wealth of information about this intriguing exoplanet. By studying its atmosphere, scientists hope to learn more about its potential habitability and whether it could support life as we know it. The launch of JWST marked a new era in exoplanet research, providing astronomers with an unparalleled tool to study these distant worlds. With its ability to probe the atmospheres of exoplanets in detail, JWST has the potential to revolutionize our understanding of planetary systems and the search for life beyond Earth. The atmosphere of a planet is a crucial factor in determining its habitability. It acts as a shield, protecting the surface from harmful radiation from its star, and it regulates the planet's temperature, making it suitable for life. Understanding the composition and structure of an exoplanet's atmosphere is essential for determining its potential to support life. Astronomers use a variety of techniques to study exoplanet atmospheres. One method is called transit spectroscopy, which involves observing the light from a star as an exoplanet passes in front of it. As the exoplanet transits its star, some of the starlight passes through the planet's atmosphere, where it is absorbed and scattered by different molecules. By analyzing the spectrum of the starlight that passes through the exoplanet's atmosphere, astronomers can identify the presence of specific molecules, such as water vapor, carbon dioxide, and methane. These molecules can provide clues about the planet's temperature, pressure, and the presence of clouds. Another method for studying exoplanet atmospheres is called direct imaging. This technique involves blocking out the light from a star to directly observe the faint light reflected from an orbiting exoplanet. Direct imaging is challenging because exoplanets are much fainter than their host stars, but it can provide valuable information about the planet's surface and atmosphere. In the search for life beyond Earth, astronomers are particularly interested in finding biosignatures, which are chemical or physical markers that indicate the presence of life. These biosignatures can be found in a planet's atmosphere, on its surface, or even in its magnetic field. One example of a biosignature is the presence of oxygen in a planet's atmosphere. Oxygen is a highly reactive gas and is quickly destroyed by geological processes unless it is continuously replenished. On Earth, oxygen is produced by photosynthetic organisms, so its presence in an exoplanet's atmosphere could be a strong indicator of life. Other potential biosignatures include methane, ozone, and nitrous oxide, all of which can be produced by biological processes. However, it's important to note that not all biosignatures are foolproof indicators of life. Some of these molecules can also be produced by abiotic processes, such as volcanic activity or chemical reactions in the atmosphere. The search for biosignatures is a complex and challenging endeavor, requiring careful observation and analysis. However, the discovery of even a single unambiguous biosignature would be a revolutionary event, confirming the existence of life beyond Earth. The discovery of exoplanets, particularly those like Gliese 12b that share similarities with Earth, has prompted us to reevaluate our place in the cosmos. It has challenged the notion that our planet is unique and has opened up the possibility that life may be abundant throughout the universe. The search for life beyond Earth is not just a scientific endeavor, but also a philosophical one. It forces us to confront fundamental questions about the nature of life, the origins of the universe, and our place within it. The discovery of extraterrestrial life, even microbial life, would have profound implications for our understanding of ourselves and our place in the cosmic tapestry. The vastness of the universe and the sheer number of stars and planets it contains suggest that life may have arisen on countless worlds. The possibility of encountering other intelligent civilizations is both exhilarating and daunting, raising questions about our own future and our place in a universe teeming with life. As we continue to explore the cosmos and unravel its mysteries, we must remain open to the possibility that we are not alone. The discovery of life beyond Earth would be a transformative event, fundamentally altering our understanding of the universe and our place within it. The field of exoplanetary science is rapidly evolving, with new discoveries and technological advancements occurring at an unprecedented pace. The coming decades promise to be an exciting time for exoplanet research, with new telescopes and missions poised to revolutionize our understanding of these distant worlds. One of the most anticipated upcoming missions is the European Space Agency's PLATO, Planetary Transits and Oscillations of Stars mission, scheduled for launch in 2026. PLATO will search for Earth-sized planets in the habitable zones of nearby stars, using the transit method to detect these elusive worlds. Another promising mission is NASA's Habitable Exoplanet Imaging mission, HabEx, currently in the concept stage. HabEx would be a large space telescope designed to directly image Earth-like exoplanets and search for signs of life in their atmospheres. These missions, along with other ground and space-based telescopes, will provide astronomers with powerful tools to study exoplanets in unprecedented detail. The future of exoplanetary exploration is bright, and the discoveries we make in the coming years are sure to transform our understanding of the universe and our place within it. The search for life beyond Earth is a journey of discovery, and the answers we find may forever change our perspective on the cosmos and our place within it.